Okay, problem number 1 says points A, B, C, D, and E are points on the circle shown. How many different triangles can be formed by joining any three of these points? And they note that joining A to B to C is the same triangle that's formed by joining B to A to C. So basically what they're saying is that the order of the points doesn't matter, which makes sense because if you connect any 3 points to form a triangle, it doesn't matter what order you connect the points. It's the same triangle. So first of all, I'd like to give you a hint. That way, if you haven't done the problem yet, you can listen to the hint and then continue working on the problem, and then come back and watch the rest of the solution. But so the hint I have, there's actually several ways to approach this problem. So I'm going to give you actually like 3 hints. Because there's a number of ways that you can approach this problem. One way is to just work very systematically and list out all the sets of 3 points that you could pick to form a triangle, because any 3 points that you pick, if you connect them up, it's going to make a triangle. So one way is just to work very systematically. Start with point A, connect A to B and find all of the triangles that you can form with a side AB, and then connect A to C and find all the triangles that you can form with AC that are different from the triangles that you found using the side AB, and then go to side AD and so on, and then once you have all the triangles that you can form with point A, then move to point B and find how many additional triangles you can find using point B as a vertice of the triangle. So, and again, just keep work. Once you have all the triangles that involve a vertice at B, then you can move to point C and find how many additional ones you can find, and so on. So just work very systematically and then count up how many you can find. So that's one way to do it. Another way to look at the problem is to recognize that whenever you choose 3 points to include in a triangle, you're automatically leaving out 2 of the points. So the number of ways that you can choose 3 points from 5 is the same as the number of ways that you can choose 2 points from 5. Okay? So so you could use that fact and to find the number of ways, the number of triangles. So instead of counting the number of triangles, you're essentially counting the number of sets of 2 points out of 5 that you can find, and that will be the same as the number of triangles. And the third way involves combinations. Now, if you haven't studied combinations and permutations, if you don't know the mathematical definition of a combination, then don't worry about it. I'll be posting some videos, some video lessons on combinations and permutations, which should help you to learn that concept, because it's a very useful tool. And if you know combinations, then you might recognize this as just a classic combination problem. So essentially you have 5 points and you want to choose 3 of them to form a triangle. So that's just a classic combination problem. And order doesn't matter, so that's why it's a combination instead of a permutation. Okay? Or you could look at it as you have 5 points and you want to choose 2 of them to leave out of the triangle, and order doesn't matter. And that again is just another classic combination problem. So those are my hints, and I'm going to go ahead and work through the first method here, and then I'm going to stop the video and record the other methods in separate videos so that I can post them on YouTube, because I have to limit my videos to 10 minutes. So let's just work very systematically. Let's start with point A, and I'm going to connect A to B and look at all the triangles that I can form using that side A, B. And so you can see the third point that we can choose could be C, so we could form a triangle ABC. We could form a triangle ADB, ABD, or ABE. So there's 3 triangles that we can form using the side AB. So let's just list them out. We have ABC, ABD, and ABE. Okay? And so that's all we can do with the side AB. So let's get rid of these triangles and let's move on to the side AC. Well, let's see how many triangles we can form using a side AC. And so we could connect it to D, or we could connect it to E. And so that's 2 more triangles. Let's list those out. So we have A, C, D, and A, C, E. All right. And you can see we left B out because we're trying to find all the additional triangles that we can find using AC. And since we've already found all the triangles using a side of AB, we don't need to count those. We're just trying to find the additional ones. So let's keep working systematically. That was side AC. We're still working with point A, and let's go on to AD. And the only additional triangle we can make with a side AD is ADE, because we've already found all the triangles with side AC and side AB, so we can leave those out. So this is the only one that involves vertice A that we haven't gotten so far. So so that's it. That's all we can find. Oops, you know what? I just realized I wrote ACE and I meant to write ADE. Let me fix that. I meant ADE. Okay. So that's all we can find with point A, because we could move around to side AE, but we'd have to choose a third point to make a triangle, and we've already found all the triangles with AD and AC and AB. So we've got all the triangles involving point A. So let's just keep moving around the triangle. Let's go to point B. We'll connect B to C, and you can see that we could connect BC to D or BC to E to form triangles. So let's list those out. BCD and BCE. Okay? And we can keep moving around the triangle, or moving around the circle. We've got the triangles with BC, so let's connect B to D. And the only triangle that we don't have is BDE. So we can list B, D, E. Okay? And that's it for point B, because again, if we went around to the side BD, we've already connected it to C, D, and A, so there wouldn't be anything new. So let's move on to point C. Connect C to D, and the only triangle that we don't have is CDE. So let's list that here. CDE. All right, and that's it for point C. And you can see that that's all there is together, because if we move on to point D, we've already connected D to C and B and A, and so we've got all those triangles, right? If we connect D to E, then we'd have to choose A, B, or C to make a triangle, and we've already gotten all of those triangles listed. So let's just count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the answer is 10 triangles. Okay? And that's just using the systematic method. So take a look at the other videos for the other solutions to this problem.